Hey, welcome to our first class. Thought I'd dress up since it's our first official homework. So just as a reminder, after each class, I will be posting a video that I'd like you to watch sometime before the next class that we have. There's no official homework as far as doing something and handing it in. Just watch these videos at your speed, so feel free to pause, rewind, watch something a second time if I was, maybe went too fast. Because I am going to try and go quickly through these so that they don't last too long. What we're going to do today, I'm going to talk about a few things. First, we're going to talk about the rules of exponents, which should be a bit of a review. And then we're going to talk a little bit about scientific notation. And then I'm going to show you an example of a quiz that I've given in years past with all of the problems worked out for you. So let's go ahead and get started with some rules of exponents. All right. Did I hit play? That's the question. There we go. So to start off with, anytime you've got a like base that's being multiplied, so a to the fourth times a to the seventh, that's going to be a to the 11th. You basically keep the base the same, and you're adding the exponents. Now, why does that work? The reason that works is b squared is really the same thing as b times b. And b cubed is really the same thing as b times b times b. And what's in between the two things? Multiplication. So really, if you think about it, that's just b multiplied by itself 5 times, which is the same as adding the 2 and the 3. So that's a simple way of knowing how to multiply like bases. Now here, you can see I'm dividing like bases. I got c to the 8th over c squared. That's the opposite. So now we're subtracting. We're getting c to the 6th. And again, why does this work? This one, I'm going to fast forward a little because I show it, and it takes me a few seconds to write it out. So d to the 4th over d, that's like d times d times d times d, so 4 times, and then over that 1d. And so those d's cancel, and you're left with d cubed, which is the same thing as doing 4 minus 1. Because even though it's just a plain b, there is a 1 there we don't want to forget about. So what's another type of thing that can happen with exponents? Well, sometimes you have an exponent raised to another exponent, like this, e to the 4th squared. Well, again, think of what squared means. That just means something times itself. So e to the 4th times e to the 4th, add those exponents, that's e to the 8th. Notice that's the same as just doing 4 times 2. So here, if I've got e to the 7 to the 5th, that's just going to be e to the 35th because you multiply 7 times 5. I wasn't going to write out e to the 7th times e to the 7th times. I was just being a little lazy. But that's an example of something that can happen. Now, what else? What's another thing that can happen with exponents? They can be negative. So if I have f to the 4th times f to the negative 7th, that's f to the negative 3rd because you just add the exponents. 4 plus negative 7 is negative 3. Now, we sometimes don't like having exponents that are negative. So what do? If we have an exponent that's negative, I'm going to pause it there for a second. Anytime you've got a negative exponent, if the instructions say that they want you to make that a positive, meaning you only have positive exponents, we need to move that base, so in this case f, to the other side. Now what I mean by other side, I've kind of given it away here by how I've paused it, but what it means is the other side of a fraction. And even though here in green there is no fraction, hopefully you remember that anytime you've got any number, and if it's just like 32, that's really 32 over 1. So really this f to the negative 3rd is over 1. So I need to move this base, this f, to the bottom. And when I move it to the bottom, it's negative 3 becomes positive 3. And so that's what this answer would look like. F to the negative 3 is the same thing as 1 over f cubed, positive. So that is something to do with negative exponents. Now here's where I show a different example, a different way of thinking about this. Okay, so I'm going to pause it there for just a second. H to the 5th over h to the 11th. if we think about this, this is dividing like bases. So we're going to subtract 5 minus 11. Hopefully you know that that's negative 6. So one of the possible answers is going to be h to the negative 6th. But if the instructions say that they don't want a negative exponent in your answer, we're going to have to think about this slightly differently, okay? So what I'm going to do now is I'm going to write out the full version. H to the 5th means h times h times h times h to the 11th, h times h times 11 times. So I'm going to write that out, and I think it actually takes me a second to write it out, so this is where I am going to just fast forward and say like, or, here's me writing out all of those h's. Okay, so I think I counted this out correctly, but now what we're allowed to do, if we expand all those h's out, we can cancel until we've canceled all that we can cancel, and what's left? Well, you'll notice there's a bunch of h's on the bottom. In fact, there are 6 of them that did not get canceled out. Now, on the top, everything got canceled out, so what's left over? Just the number 1. So, what this means is the answer here, h to the negative 6th, is the same as 1 over h to the positive 6th. So these two answers are interchangeable. It just depends on the instructions that the question gives you. So if the question said, write your answer with only positive exponents, you would have to give this answer. If the instructions just said, write your answer, simplify the fraction, and it doesn't say anything about positive exponents, you could give this answer and it's correct. It's the same thing as this, but I will tell you most of the time, mathematicians, we like to have positives. So this answer down here in the corner is most likely what you would be given. Excuse me. Okay, let's see. What else are we going to talk about here? Are we going to move on? Or yeah, there we go. I was like, what's going on? All right, now let's talk about scientific notation. This is something you've probably seen before. You might have had a little experience with. But really the point of scientific notation is it exists so that we can talk about numbers that look really long, and we can talk about them in a much more condensed space. An example would be if you ever hear somebody say the number like 37 million, it's faster to say 37 million than it would be to say 37,000,000. So that's why the word million even exists, is so that we can say things faster. Scientific is the same. Scientific notation is the same for writing. It's a way of writing a really long number in a condensed space. So scientific notation has a common way of writing it. You have a number and then a times sign, that's not an x, times 10 to the, and there's an exponent here. This number has to be between 1 and 10. Now you notice I put a bracket here and a parentheses there. This is something that goes back to when you're talking about inequalities. A bracket means you can equal 1. So the smallest number that could be right here in this number place is the number 1. And here it could go from 1 to 10. Now I put a parentheses with 10 because parentheses in that notation means you can't touch 10, but you can get really close to it. So what's the biggest number that could go here? It can't be 10, but it could be 9.9999999. Really close to 10, but not actually 10. So this number at the beginning is somewhere in the 1 almost to 10 range. So that's the first part of scientific notation. The other part is this exponent. I put a blank there because there's some exponent after the 10. And if that exponent is a positive number, positive 7 or positive 30 or whatever, if it is a positive number up here, that means that you are talking about a giant number, a really big number, okay? On the flip side of that, if that's a negative exponent, then that means that you're talking about a tiny number, 0.000000044 or something. Okay, so if it's a negative exponent, tiny number, positive exponent means you're talking about something very large. So that's the general scientific notation rules. Now, I wanted to do a couple of examples just so you could see how to convert from standard form, this is what's called standard form, to scientific notation. Now, this might be kind of an easy number to say. To say this number, you'd say 478 billion. But it was kind of annoying to write this down. Even when I did this a few minutes ago when I was writing it, it's a pain to write this down. So scientific notation is there to help us write down numbers in a less annoying way. So, where do I need to put a decimal point in this number so that that beginning number is between 1 and 10? So think about where would you have to put the decimal point to make it be between 1 and 10? It would have to go right here between the 4 and the 7, because that would be 4.78. If you put it between the 7 and the 8, that'd be 47.8, and that's bigger than 10. If you put it in front of the 4, that would be 0.478, and that's smaller than 1. So it has to be 4.78, and I think you'll see me draw the little decimal point in there. So that means at the beginning of my scientific notation, I'd have 4.78 times 10 to the, and now we count. How many places did I just move over? 11. So that's the scientific notation for that very large number. Now, what about taking a number that is very tiny? Something like this, 0.0000000032. Now, this is a tiny number, so if we think back to the last screen, that means we're going to have a negative exponent, whereas this one had a positive exponent because the original number was very big. So with this tiny number, I need to think, where does the decimal place need to go so that it's from 1 to 10? And it would go between the 3 and the 2, so that it's 3.2. And if we put it there, 3.2, that means our scientific notation will start 3.2 times 10 to the, I know it's got to be negative, and now it's just a matter of counting how many places did it move from here to there, and it moved 9 times. And it has to be a negative 9 because of the fact that it was a tiny number. Okay, now we actually sometimes will use operations with scientific notation. You might have to do something like this, where you've got 4.2 times 10 to the 7th times 2 times 10 to the, let's see, what did I make it here? 2 times 10 to the negative 3rd. Now, when you've got something like this, in between the two parentheses is a times. In between the 4.2 and the 10 to the 7th is another times. It just looks different. This is because when we write scientific notation, we write it like this. In between the 2 and the 10 to the negative 3rd is another times. So basically, what's in between all of these things? It's just multiplication. So if there's multiplication between everything, we can reorder it and do it in whichever order we want. So what I think is going to be easiest, and what you all should think is easiest as well, is multiply the 4.2 times the 2, because those are just numbers. They aren't exponents or anything. So 4.2 times 2 is 8.4. So that's the first thing I would write down, 8.4. Times 10 to the, I started to give it away. Here, you have 10 to the 7th and 10 to the negative 3rd. You're multiplying like bases. They're both 10. So what do I do with the 7 and the negative 3? I add them. 7 plus negative 3 is the same as 7 minus 3. You can see I started to write the 4 right there. So this also works in an example like our quiz here. This is a quiz that I've given in years past. And I skipped the first 2 questions because this was a partner quiz and I based it on something else. Now, this might seem kind of small. I don't know if you can like look more closely at your screen. I probably should have zoomed in a little bit, but I'll read the question to you kind of quickly. I'm not going to read every word. Basically, it says that there are approximately 4,400,000 people living in Ireland, and there are about 4,600,000 people living in New Zealand. Then it says there are 324 million people living in the USA. So how many times more people live in the USA than in New Zealand and Ireland combined. So this problem seems a little tricky because there's a lot of stuff that there's big numbers, there's other things to interpret. What am I asking? What's going on here? So let's break it down. This is a word problem. This is a not too crazy of a word problem, but it looks kind of tough. So the first thing it says is that the USA has 324 million people. We've just been talking about scientific notation. So 324 million, again, easy to say, annoying to write down. So how could I write down that number in a less annoying way? Well, we would just want to write down 3.24. That's so you can move the decimal place over. 3.24 times 10 to the, I'm pretty sure it's 8th. Let's see if that's what I wrote down. Yeah. So 3.24 times 10 to the 8th. That is the USA population in scientific notation. Now to find out, and we do need to read this carefully because it says how many more times does the USA have than New Zealand and Ireland combined. So that means we need to add together New Zealand's population and Ireland's population. Ireland was 4,400,000. New Zealand was 4,600,000. Add those together and you get a nice number of 9 million people. Now, if I change 9 million into scientific notation, that's 9 times 10 to the 6th. So you can see I've already done that. I did some work in my head. And that's for these two countries added together. So how many times more people are in the US? You might think that that means do multiplication. But it actually means I need to think of how many times this number goes into that number, which means we're going to be doing division. We're going to take the 3.24 times 10 to the 8th and divide by 9 times 10 to the 6th. So I did that work. I did it in my head. You could use a calculator if you wanted, because all I did was I did the 3.24 divided by 9, and I got 0.36 as an answer. That's just from doing the number part. Now, the times 10 to the 8th over times 10 to the 6th, we have like bases. We're dividing them. So that means we take the 8 minus 6. So we're going to have times 10 squared. But this is not scientific notation answer. You might be like, wait, Mr. O'Connor, it's a number times 10 to a power. But that's actually not a number that's valid. We have to be between 1 and 10. So where does this decimal point need to go to make the number between 1 and 10? It has to go between the 3 and the 6. So this is going to become 3.6 times 10 to the, and this is where you have to really think, 1. There's just a 1 here. The exponent is 1 because I made this number 10 times larger, right? I moved the decimal place over once. That's like multiplying by 10. So if I make this number larger, I have to make this number smaller, okay? I moved the decimal place once, which means I have to subtract one of these 10s from here. So it's just 10 to the power of 1. And we don't need to write a 1, 10 to the power of 1. We can just write 10. So the answer to this problem is that the USA has 3.6 times 10 times more people. There's that many more times people. Now, does that sound like it makes sense? I don't think it sounds like it makes a whole lot of sense, saying the answer that way. 3.6 times 10 times more people. That's why the question underneath here says, what form is the least annoying way to describe this answer? I think the answer we just said was kind of annoying. I don't like saying 3.6 times 10 times as many people. So could we convert that answer that we just got, 3.6 times 10, could we convert that back to standard form, the way these numbers started at the beginning with like 4.4 million and all that? So to get 3.6 times 10 back to standard form, we just do 3.6 times 10, which is 36. Doesn't it sound a lot more normal to say there are 36 times as many people? rather than saying there are 3.6 times 10 times as many people. Way easier to say 36 times as many people. So standard form, the way we normally write numbers, would be the best way of saying that answer. 36 times as many people. Okay, moving on to the next one. I was like, I hope I zoomed in on this a little bit. So this next one is kind of like an example problem I did before I got to this quiz. And you can see we've got a number here, which is 24. 24 times 10 to the 8th times 3 times 10 to the negative 13th. So if you think back to when I did this problem earlier, we're just going to do 24 times 3. Write that answer down. And then we're going to put together the 10 to the 8th and 10 to the negative 13th. So 24 times 3, 72. And then the 10 to the 8th and 10 to the negative 13th would make 10 to the negative 5th. And you can see I've already kind of gotten to this next part. 72 is not between 1 and 10, so this wouldn't be correct scientific notation. So I need to make this number smaller to make it 7.2. So I've just made this number smaller. So what do I need to do to negative 5 to balance that out? If I make this number smaller, I need to make negative 5 bigger by one number because I've moved the decimal point one place. So what's 1 bigger than negative 5? Make sure you think about it correctly because it's a negative. What's 1 bigger than negative 5? It is negative 4. So that would be our answer to this problem, except for it says they wanted you to show your answer as a standard form and in scientific notation. So you can see that here I wrote that in standard form, and the way I did that is I said, okay, I know it's negative 4, which means that's how many places I moved the decimal. So I've got originally 7.2, but since it's a negative, I know it's a tiny number, so the decimal needs to go back that way. And so I'm going to move it 4 times because it's a negative 4. So I'm going to move the decimal place 1, 2, 3, 4, and that would leave me with this number over here, 0.00072. Now you can see there's some instructions here. Those were actually supposed to be on the next page of the quiz, but let's just look at those real quick. They say, completely simplify the expression using only positive exponents. So this is something I talked about earlier, is that the instructions say we have to have positive exponents. So I go to the next page, hopefully. We got 3 more problems. Oh, 4 more, my bad. And the first thing is you're going to notice that you've got negative 2 x squared y cubed. So that cubed applies to everything inside the parentheses. It's kind of like distributing. So I've got to cube everything inside. So that's why I'm drawing those little arcs, just to show I'm going to cube everything. And here, I'm going to square everything in the next one. So now I'm starting to do the work. Okay? And I'm going to pause it after I've written all that down just to explain where I got all of those pieces. So to start off with, negative 8. We had negative 2 in here, and it's being cubed. So that means negative 2 times negative 2 times negative 2. That's negative 8. Then you have x squared cubed, which means multiply the 2 and the 3, so you get x to the 6th. And then here at the end, you've got y cubed. So that's why it's y cubed. Now in the other one, we're squaring everything. So negative 3 squared is a positive 9. Negative times negative is a positive. Now if you're wondering, wait, why was this one negative, but this one was positive? That's because in the first one, we multiplied a negative by a negative by a negative. So if you multiply a negative 3 times, it will stay negative. Here, it was just twice, so it's positive. And in the rest of it, square the x squared, and square y squared, which is y to the 4th. Now this is still multiply in between, so I've still got more work to do. I've got to multiply everything together. So the first thing I'm going to multiply are the coefficients, the numbers. Negative 8 times 9. Negative 8 times 9 is negative 72. X squared, I looked at it wrong. X to the 6th and x squared makes x to the 8th, and also y to the 7th. Hopefully you can follow along how I got that. Now this next problem looks tough. And whenever I give this quiz, people mess this one up. But if we think about it, it's actually kind of easy. Because if we look at the numerator, let's just put these t's together, just in the numerator. T to the 5th and t to the negative 5th. Those are like bases. So what do we do with exponents that have like bases? Add them. So what's 5 plus negative 5? 5 minus 5. So that would be t to the 0 over t to the 9th. Something we haven't talked about, but I assume you've heard at some point, is anything to the 0 power is just 1. Just 1. Regular 1. Now, there's other ways of me explaining that. So if you want to hear that, maybe ask me in class tomorrow, how do I know that? But for right now, that's just something we want to know, is that t to the 0 is 1. So that's going to be a 1 over t to the 9th. So you can see why I say that one, if you know your rules, it's not as bad as it looks. Okay, something I say to my students at the very beginning of the year. When you look at fractions being multiplied, a habit that you were taught in years past, we need to break away from that habit. Okay? Students that I taught know where I'm going with this. We have to break ourselves of the habit of just multiplying straight across. That is not what you do when you get to advanced level of math. Beginner level, the way you learn it, sure, that's what you do at the beginning. But now we know more, and we are able to do more. So what we do instead of multiplying straight across is our first step is to try and look diagonally. Can I look diagonally here and get any of these things to cancel out? So the first thing I noticed is I looked diagonally and I saw the 4 and the 8. And I was like, hey, those cancel. So you'll see I do that. So I cancel the 4 and the 8, and the 8 turns into a 2. Now I start doing some other, this is where if you want to pause and really watch what I'm doing, you can, all right? But this is where I really start canceling a lot of things. So I was left with a 4 over 5, because this 2 times this 2 is 4. This 5 is the only thing left on the bottom. Now I start dealing with my x's, and you'll see I'm using blue color to deal with all the x's. And there's a variety of things that I have to do. The biggest one you might have a question about is why did I circle this x and put an arrow pointing to the bottom? The reason for that is that this x has a negative exponent. So to make this exponent positive, I got to move it to the bottom. Last thing, you can see I've already started to do this a little bit in green with the y's, is I'm going to start canceling out the y's in green. And as I go through this, that's all that's left. There's your answer. Okay? Now, the extra credit question. Oh, man. What do you think? Pretty good one? Yeah? Here's something that will make it way easier. It's still not easy, but way easier. Can you see the exponent that's right here? Outside of the parentheses, meaning it refers to this entire big, nasty fraction. That's a 0. And what did I say a few minutes ago? Anything to the 0 power is 1. So that entire second fraction, because it's to the power of 0, this whole thing cancels out. It's just 1. You're just multiplying by 1, which means we don't need to focus on that at all. Multiplying by 1 doesn't change anything, so I just need to focus on this. Now, I'm not going to explain every single step here. I'm going to let you kind of just watch what I do. So the first thing, I'm distributing all of those exponents. And here's what I get from that, okay? So I'm just going to let you kind of watch as this goes through. And again, if this gets confusing, make a note of what confuses you and bring it up in class tomorrow. There is a lot going on. I understand that. So now I've done all the distributing, and now I've got to start getting rid of negative exponents. We don't like negative exponents. I said that a little bit earlier. So to get rid of negative exponents, I've got to move the base that has a negative exponent. So you're seeing me circle all of these bases that have negative exponents, and I'm moving them either down or up, depending on where they need to go. And this does get a little messy, okay? But this is going to help you keep everything organized. So there's still my big fraction, and now I'm going to write things with positive exponents in their new locations. Okay, now everything has a positive exponent. Now we got to start putting things together. So across the numerator, I'm going to start putting stuff together that goes together. Now those two 16s that you see, that comes from negative 2 to the fourth. So negative 2 times negative 2 times negative 2 times negative 2 is 16. And on the bottom, 4 squared is also 16. The A, B's, and C's across the top, that just came from combining all of the A, B's, and C's. And then I put this 8 here. It was back here towards the end, and I just moved it up towards the front. And now we can start doing some canceling. 16's canceled. Cancel out some A's. The 8 is the only thing left over on the bottom. Cancel out the B's. Where do the B's end up? There's actually more on the bottom, so the B's end up on the bottom. And then the C's end up on top because there's more on top. And that's it. So that is our homework for today. 32 minutes, way too long. My bad. I want to make these shorter because I don't want to take up your whole afternoon. So this was day 1. My bad for squeezing so much in. I'll try to make these shorter for tomorrow and the days in the future. Thanks for watching. Please bring any questions to tomorrow's class. I'll see you then. Bye.